Hey guys, happy Halloween. You get to see what my costume was for the night. Um, I'm going to go ahead and walk us through fiber slides. There's a lot of videos in these notes that I am going to link. I can't actually show them in these video slides because last time I tried, the individual who showed her yarn burning, when you watch that video, she actually copyrighted me because I had had it in the saved slides. So anyways, I'm going to link all of those videos, so you guys are welcome to either watch them all at the end. Each one is between 3 to 5 minutes, or you can pause this video, watch a different one. But I think just for ease sake, it would probably be easier to just watch them all at the end. Put them on 1.5 or even 2 times speed. More so, those videos are included for you to have some context regarding fibers, how they're created, what we do with them, etc. So that helped kind of solidify this information then in into more context. So anyways, enough of that. Let's go ahead and get through fibers. So what are fibers? Fibers are everything that we interact with, essentially, that is made out of a certain kind of textile, and it'll shed small fragments that stick with us. We carry them around everywhere. So when it comes to textiles and clothing, what is shed is known as a fiber. So wearing clothes, you're going to be shedding fibers around. Sitting on a couch, you're going to be picking up fibers from the couch, and you're going to be shedding the fibers from your clothes on that couch. Walking on a carpet while wearing socks, not only are you making static electricity, but you're transferring fibers between your socks and the carpet. So fibers are everywhere. They come from everywhere. They are spread and picked up and shared, which is why they're actually a very effective form of evidence. They are, while technically considering it a class evidence, you can almost use it as individual due to how easily small fibers are shed. And if you think about it, even though so many people might have the same white t-shirt from H&M, pairing that with then a certain pair of denim jeans from Forever 21, I'm just throwing mall brands out here, having then the specific pair of jeans, but then a specific pair of socks, jacket, etc., the more articles of clothing that you're able to identify what the fibers then belong to, the easier you can then put together an idea of the perpetrator, right? And that's what's able to convert this from class evidence to something that's almost like individual evidence. And another unique part about this is that fiber evidence is often unnoticed by criminals. It's normally left behind because it's so insignificantly small that it actually becomes significant, right? They don't really think to pick up each of the individual fibers that they shed, as opposed to making sure to wipe off fingerprints and things like that. So same with hair, fiber can be transferred as a form of trace evidence following Locard's principle of exchange, and we see direct and secondary transfer. So direct transfer, maybe like shirt to shirt, or maybe from shirt to fall on the ground to then get on your sock to then be spread on the carpet as secondary transfer. So we should be pretty familiar with direct versus secondary since we talked about it in our most recent unit with hair. When it comes to fiber collection, it's all about time because quick collection of fibers is critical. Within 24 hours, about 95% of all fibers have been lost. So they might have fallen from the victim or have been lost at the crime scene. So it's really important that we collect those as quickly as possible. And in terms of the fibers that we collect, it's fibers that we don't expect to see as evidence. So pink fibers on the shirt of a victim found in a white room, it's going to stand out, versus if it's a pink house, pink walls, pink carpeting, pink furniture, finding then a pink fiber isn't going to stand out as much, right? So it's about what is applicable, what is actually, the word I'm looking for here is applicable evidence. There's a different word, but we'll move on. Fun fact though, dead bodies are covered in plastic instead of cotton, since cotton fibers are a potential contaminant. So that's why we see plastic tarps on top of the bodies that are pulled from crime scenes. So when we're analyzing fibers, there's some critical details that we need to observe. The type of fiber, the fiber color, the numbers that were found, where it was found, the type of textile, if there's multiple types of textiles, the type of the crime, and then the time between crime and discovery of fiber. So there's some more specific parts here that we want to lend to. The type, what is the composition of the fiber and how common or rare is it? The color, what type of dye does the fiber have? Does that match the crime scene? The number, this is interesting because due to Locard's principle of exchange, the number of fibers then helps us learn a little bit more about the actual type of crime that occurred, as well as how long that crime occurred. So if there's not that very many fibers, and you could imagine that there probably wasn't too much physical interchange. But if there's a lot of fibers at the scene, well, then you're obviously going to be a little bit more expectant of a higher violent crime, of more physical contact, of a longer duration of contact. So the amount of fibers present is really indicative as to the level of intensity of the crime. Where can you find these fibers? How close can you place them to the scene of the crime, especially if it's like a suspect's fibers? So when we do an activity about O.J. Simpson, you'll be able to see how the placement of fibers was really critical to analyzing evidence. Textile, so what was the main textile source? So did it come from the carpet? Did it come from the car? Did it come from a hat or a beanie? Transfers, is there more than one type of fiber present? So similar to the amount of just strands of fibers present, having more sources of fibers or types of fibers also suggests longer contact period or higher possible degree of violence. And then that then attaches it to the actual crime itself. So was the crime violent? Was it a kidnapping? Each crime has an expected pattern of contact. So choking is going to look different than assault from fists, for example, versus assault with a weapon. You would expect fibers to be shed in a specific way that would help you then kind of put together the sequence of events to identify what happened during the crime. Time, how long ago did the transfer take place? So remember, that goes into the collection of evidence. So about 95% of fiber evidence is lost within the first 24 hours. So how long ago did the transfer take place then helps us identify that sequence of events. So when it comes to collection, we might use forceps, which are tweezers, special vacuums, or sticky tape. And documentation, of course, just like always, is really important to establishing the chain of custody. So once you're in the lab, you want to identify the type of fiber and its characteristics to then be able to match it to a source such as the suspect, form of transportation, the car, home. And there's two different ways that we can analyze this, two different categories of analysis. There's destructive and non-destructive. So if we only have one type of fiber, you don't want to destroy the rare amount of evidence that you have, right? So you wouldn't want to damage that fiber. You wouldn't want to use a destructive test. So what you would do is polarizing light microscopy, or infrared infrared spectroscopy. So those are non-destructive because you're just able to analyze it there. If you have a large amount of fibers and can use destructive tests, then you're going to be able to burn them. Burning fibers actually reveals a lot of details about its composition, as well as potentially dissolving it in various liquids. So when we do fiber analysis labs, we will have the opportunity to see just how much you can learn from these different test forms. So this is one of those videos. This is actually the reason that I can't play it in these virtual slides because I'll get copyright claimed. But this is a video that goes through those different burn tests with a variety of different fibers, and it is very, very informative. So definitely recommend watching this one. Expect that you have to watch all of them, right? So when we're looking through a microscope, using a microscope with a special filter that allows us to then choose different wavelengths. So do we want to go more on the red spectrum, the blue spectrum, the yellow spectrum? That allows us to then identify different details of the fiber itself. Also, natural fibers only require ordinary microscope, so that's an easy way to be able to identify, are we working with a man-made or a natural fiber? If it's natural, then great. We'd be able to look at it with just the ordinary microscope. So some examples of natural fibers that come from animals, plants, or minerals are mined from the ground. So animals provide fibers from three main sources: hair, fur, or webbing. All animal fibers are made of proteins called keratins. That's our hair, that is our fingernails, that is the hair of an animal, their fur, if it's like horn or hoof, right? So keratin's a protein, and it's going to behave in a very specific way that then allows us to identify that this fiber comes from animals. So furs are made by drying an animal's skin with the fur attached. That's just the leather and the fur. That's kind of like a cow or a bear rug, right? Hair fibers themselves are most popular, so the most common being wool from sheep, but also including cashmere that comes from a specific kind of goat. Angora comes from a specific kind of rabbit. Alpaca wool, silk comes from a silk moth, right? And the thing that's interesting is that because these are natural, when you burn them, they smell like burning hair. So it's easy to identify. So the hair is collected via brushing, clipping, or waiting for the animal to shed naturally. Silk is collected by the cocoons of the caterpillar Bombyx mori, and then it's actually unraveled by hand, pulled apart. It's a single thread makes the cocoon. And so because these fibers are really long, it's a very long thread for each cocoon, they are not shed very easily. So wearing something silk, which actually what I'm wearing right now is silk, it wrinkles easily, but it will not shed fibers easily, because it's kind of just one long strand. So I'd recommend watching these two videos, how silkworms made silk and why cashmere is so expensive. I will have these linked to this video on Schoology. So plant fibers are cellulose fibers, and these are created by specialized plant cells. And these are actually a carbohydrate, not a protein. So that changes their behavior. It also makes them very resistant to chemical damage, and it makes them insoluble. Plant fibers themselves vary greatly. They might be thick, stiff, smooth, elastic, absorbent, or even amorphous. So I have a few examples of different kinds here. The most common is the seed fibers of cotton. So this is found in the seed pod itself once it breaks open. There's fruit fibers, so this is known as coir. It's made from the exterior of a coconut. Stem fibers here is made from flax stem, so that linen is very common. And this is unique because linen has a crystalline structure, and it's dense, strong, and long-lasting. Meanwhile, leaf fibers are made of manila, and this is made from the leaves of an abaca plant. And there's a lot of different applications for these, as well as the fact that when they burn, because they are plant origin, they smell like burnt paper. So this video goes into the most common form, cotton. And then we get into mineral fibers. So mineral fibers are neither protein or cellulose, and they come in a very large variety. For example, fiberglass, this pink insulation that you will see in between walls, this is made of thin strands of glass. It's used to insulate buildings, and because of the fact that it's made of these very thin strands of glass, the fibers are fine and they can cause skin rashes, so you don't want to touch fiber from glass. Asbestos, which we probably have heard of, right? It's damaging. It's a mineral naturally occurring in different types of rocks, and it's very durable. It covers pipes, floors, and ceiling tiles, fire-resistant clothing, etc. So I have a video here that I encourage you guys to watch about the real story of asbestos, why it's damaging, how it forms so that you can be able to identify its crystalline structure underneath the microscope. So now we are transitioning to synthetic or man-made fibers, and these are made by joining monomers together to form polymers. And there's a variety of different forms of man-made fibers, one of which being regenerated fibers. So these are derived from plant-based materials, but then they are man-made, they're chemically altered. So they're mostly plant-based in origin, the most common being rayon. This is generally smooth and silky. So the way that this works is, you'll be able to watch it in the next video that's attached to this, but essentially there's a few different chemicals at play that you'll use to then dissolve a large amount of cotton, and then that is then turned into strands that you can then spread out there. So there's other ideas such as cellulose, which is chemically combined with acetate to produce celanine, and this is used in carpets. And when cellulose is combined with 3 acetate units, it then forms a polyamide nylon, which is known as Capron. So this video, like I said, will show how we make rayon. And then there's also synthetic polymer fibers. So these are completely man-made from petroleum or oil. which can then be customized for specific purposes. Their properties depend on the formula itself, the shape of the spinneret, the dye, etc. And polyester is very common. It's one of the most common synthetic fibers, and the reason that it is so common is that it's resistant to light and acid. So it's very durable. And this next video that you'll see that's linked goes through how we can actually create polyester fabrics from plastic. Nylon is similar to polyester, but it's easily broken down by light and acid, so not ideal, right? Not as durable. Acrylic has a light, fluffy feel, but it tends to ball or pill easily. Olefins are used in performance clothing because they are quick drying and resistant to wear. And so this video is really interesting because it goes through how we're able to reverse engineer plastic. And I have this characteristic table here that allows you to compare the different natural fibers from synthetic fibers. In general, synthetic fibers are stronger than even the strongest natural fibers, and they also will not be damaged by microorganisms. However, they are more likely to deteriorate in sunlight, and they melt at lower temperatures than natural fibers do. So there's definitely a cost-benefit analysis. In terms of how we arrange fibers, fibers too short in their state can be spun together to make yarns, and yarns will then be twisted together in different directions, which we can analyze as seen on the next slide. But rope itself is essentially very big yarn threads. So yarn is going to either have a Z twist, which is counterclockwise, or an S twist, which is clockwise. And it can be created from nearly any fiber, natural or synthetic, or even a blend of the two. Any yarn itself will have a direction of twist, so forensic scientists will use the direction of their twist in order to then analyze the fiber for further identification. And weaving is also a form of identification. So weaving itself has been practiced since the earliest human history, dating as far back as the Stone Age. And it consists of threads laying side by side lengthwise and crosswise, lengthwise being the warp, crosswise being the weft. And you can see that there's a variety of different patterns that you can use to weave. Satin is often mistaken as a form of textile, but it's actually a weaving pattern. And so the pattern in which the weft passes under and over the warp is called the weave pattern, which can then influence the style of fabric. It also differs in the thread count, which is essentially counting the warps and the wefts, and then that gives us the thread count. So a high thread count normally corresponds with a higher quality fabric. So in this case, looking at the weft to the warp, we have 120 plus 140 equals 260, which is a high thread count. We often see this in reference to bed sheets. If you have a high thread count for your bed sheets, then it's assumed that it's higher quality. And this is all the information that I have on the slides to give you about fibers. But like I said, I'm going to link all of the different videos for you to watch. Just watch through those different videos regarding how the different textiles are made, how we can identify them, etc. And then once you're done with these video notes, to jump into the fiber self-assessment assignment, will give you a chance to practice and apply all of this knowledge. If you have any questions, of course, you're welcome to reach out to me. Otherwise, I will see you guys soon. Thank you.